So the problem I will be doing is a first order linear equation. Now the problem is number 7 from WebWork number 3, and this is the equation, and I'm going to do it with an initial condition of y1 equals 0. Just a little extra, just show how you would do it with an initial condition. So the first step, very importantly, is you want to have it in standard form, which means dy over dt has to be by itself. So you're going to multiply both sides by 1 over 4t. Once you multiply both sides by 1 over 4t, you're going to get dy over dt plus 1 over 4ty equals 1 over 4t squared. Secondly, you're going to want to get your integrating factor. That's going to be whatever term is in front of your y. And it'll be written in the form e to the integral of p of x dx. In this case, p of t dt, which is going to be the p of t is in front of your y. So you're going to have e to the integral 1 over 4t dt equals e, pull the 1/4 out, 1 over t dt, get e to the 1/4 ln of t, which is going to, you can bring the 1/4 to the top, treat it as an exponent. And now you can cancel out the e and the ln. And you get t to the 1/4 as your integrating factor. Next, you're going to want to multiply both sides by the integrating factor. Now once you do that, you want to rewrite the left side of the equation as d over dx e to the integral of p of x dx times y. So let's do that. So you're going to get d over dt, because there are t's in this problem. You get t to the 1/4 y equals 1/4 t to the 9/4. You get 9/4 when you multiply t squared and t to the 1/4. Okay. Now once you do that, you want to integrate both sides of the equation with respect to t. So you're going to take the integral of the left side, it's going to be dt, integral of this side, dt. Now the integral cancels out with the derivative of the left side, so you're just going to get t to the 1/4 y equals 1/4 times the integral of t to the 9/4, which you're going to get 13/4, and you're going to flip that over, so you're going to get 4 over 13 t to the 13/4 plus c. Don't forget your plus c. And then from there, you can cancel out the 4's. You get t to the 1/4 y equals 1/13 t to the 13/4 plus c. Now I'm just going to remove this page to get more room. So at this step, I just reduce the right side down. I'm going to continue over here. I'm going to rewrite it. So we have t to the 1/4 y equals 1/13 t to the 13/4 plus c. And now you want to solve the equation for y. So you're just going to divide both sides by t to the 1/4. So you should get y equals 1/13 t cubed. When you divide t to the 13/4 by t to the 1/4, you should get t cubed plus c t to the -1/4. Or you could rewrite it as y equals 1/13 t cubed plus c over t to the 1/4. This would be your transient term, because as t approaches infinity, the term c over t to the 1/4 will go to 0. So that's considered your transient term. Now, the initial condition was y of 1 equals 0. So we're going to plug that in and get 0 equals 1/13. Plug in 1 for your t. Okay, so you should get 0 equals 1/13 plus c. So your c should equal -1/13. So once you find your c, just plug that into your equation. Y equals 1/13 t to the 3rd minus 1/13 t to the 1/4. And that should be your particular solution. And back up top, this would be your general solution. And that's about it. That was a linear equation with an integrating factor, and I hope that was very helpful. If you have any questions, just ask what you would like to ask.